there, welcome to my YouTube channel. My name is Damilola. Today we'll be talking about Python Dataclass, how useful they are and how they can make your life a lot easier developing your Python project. Without further ado, let's get right into it, shall we? So we'll be talking about Python Dataclass today. Here I have prepared my development environment. I'm using VS Code as a text editor. You feel free to use whatever text editor IDE of your choice. We're going to be talking about data class. Data classes in Python is how it's actually, just a decorator really, which you wrap around your class primarily for modeling your data, how you want to arrange your data, right? In my previous video where I talk about object-oriented programming, which is essentially how you model, data really, and which these data are objects, right? When you're using data class, you do the same thing, except that data class has simplified a lot of things for you with Python OOP, using the OOP approach, using you declaring your class and then declaring your fields and your constructor and all of those. Those can be really a bit of a chore sometimes. With Python data class, this streamlines that bit of work for you. I'm going to show you how you would do it if you were using if you had to declare these fields yourself, and then I'll also be showing you with the data class, and you can see how effective and how productive this can make your life in development, right? So let's not do too much of without further ado. Let's get right into let's jump right into the code. So here for instance, now I'm going to define a class for student. So let's say class student. By the way, my bad, let me bump this up on my screen, the font size. Let's bump this up a bit so it's easy for everyone to see. So what I have done here, like I said, I have prepared my development environment. I use Poetry for my virtual environment, so that's why you see this here, say PyProject.toml. I really don't have any dependency whatsoever other than Python. So yeah, I'm going to declare a class. By the way, if you are not familiar with the idea of OOP, object-oriented programming in Python, I'm going to put a link in the description below of my last tutorial talking about Python object-oriented programming. You might need to check that out if you don't have any idea of what OOP is first before you come back to this. But even if you are not, I'm sure you can still follow along and catch up with that video in the description. So let's get right into it. So for instance, now let's say we have this concept of a student and we want to model that. The approach of we want to create this object of a student. So without the data class concept, so we will do something like say class, we'll say student. Okay, so student, and of course we are going to initiate our constructor. By the way, all of these I explained what they are and how they work in the object-oriented programming with Python, like I mentioned, which I'll leave the link again in the description. So let's get right back in here. So our student in this case would have, say, a name. Our student, let's add some type annotation here. Our student will have a name. Let's say our student also have what's a particular course that they did, right? Let's just give the course a string, and they have a grade which would say their grade is we'll use numbers in this case, so let's say over 100. Okay, okay, I think it would be nice to know their age. Maybe we should put that way ahead. let's just put, just for some more fields purpose, say age is int. All right. By the way, if you're not familiar with type hinting, if you would like me to make a video about this, please drop that in the comments. So I'll definitely, I'm more than happy to make a video about that. If you would like to see something about type hinting, type annotation in Python. Anyways, back to the subject of subject matter here. So now we are going to take the name, the age, the cost, the grade as an of a student. So we'll do something like say self dot name, equals name, self dot age equals age, self dot scores, self dot grade is great. All right, and like so we can instantiate this to get the object of a student. So let's create a student. Let's call this student Davis. To do so, we are going to say, of course, we need name. Say name is Davis. Say age, and let's say age is 20. Okay, and let's say the course is physics. Interesting. Let's say grade. Let's say he got like, well, he got a really good grade, so let's say he got 60, right? For the grade. So we can do something like print Davis, and if you try to see main.py, if we run our code here, so as you can see here, what we are getting here is an address to this object that has been created. Student object is at this particular address. This is not exactly very human friendly. If I was not the one that wrote this, now I don't even know what this address is. I do not understand what this is, so let's make it a bit human readable, that we can understand what we are saying. So we would need like a representation of some sorts of the object, so we can implement one of those another magic function. We can do string representation, or we can just do representation itself. So let's just do representation. Okay, and here let's just say we want to return the name of the student as our representation. Okay, and if we run our code again, now we see Davis. Okay, something else we can do, we can put as many information as we want here. So we can do but I think Davis, just the name of the student is fine. Maybe we want to see the scores, so let's do something like yes, the string representation with f string. So let's say the name, let's say self the course, which is physics, and maybe we want to make this a way that we can actually read better. Let's say name. We can escape to a new line, just for demonstration purposes, and say course is this. All right, and we do something like say, by the way, that says new line. I'm just putting that out there. Okay, let's just do grade and say self dot grade. All right, okay, we have age as well, so self dot age. Okay, all right, so if we run our code here again, you can see we have, I think we didn't do one of those. Which one? Oh, we missed it after age. So we want to put everything on a new line, so it looks nice and clean, right? So we have name Davies, age is 20, course is physics, and then he got 60, right, in this particular course. We can then, let's do Raven. Let's do another student called Raven. Say student's name is Raven. Age is 22. Okay. We do course is also physics, and let's say grade. Let's say Raven is such a amazing student. He or she got like what, 80, and let's print that. Let's print Raven as well. Okay, we can do a nice separator here. You'll see the point in a minute. Where this might be a little bit exhausting, but you see, you get the idea. So we have Raven, we have these students called Davis. We also have these students called Raven. Now here's the thing. Maybe I should reduce this font a bit. I hope we can all see this clearly. So here's the thing, okay? We had to literally, do all of this initialization. And if you look at this class, we are not exactly doing anything really as of this point. All we are doing with it is to, keep the data object of student. All right. So essentially, we are using it as a model for our students' information. Okay. Another thing you will notice here is that these objects are different. If we didn't have this string representation, you will see that it's pointing to different address. Each instantiation is different. Another interesting thing here is that let's say we wanted to, like I mentioned earlier, everything here is modeling the student object. But we don't have to do all of this work really. If with data class, all of this initialization of the fields have been done for us, which means you don't necessarily have to write the code for it, right? And which is great, because you don't have to worry about have to worry about it. Let me show you how you can do it. So if you go to do that, we can import something called, I'm going to comment all this on out, and we are going to implement the same thing using data class, what we've just implemented here. So if we do from something called from data classes, and then you import data class. Okay. And we are going to, like I said, we are going to represent the same thing again with data class. So, and see how straightforward and how easy it is to take advantage of it. So it's a class student. All right. The fields we have were name, all right, and name was string, and we had age, which I believe was integer. We had the course, all right, which was a string. We have grade, which also, I believe that's an integer. That's an integer, all right. We only need to do one thing now to make this a data class by adding the decorator, this data class decorator that we've imported. Say data class, all right. And just like this, we can do, and what this essentially does for us is like this data class decorator, beg your pardon, as will do all of this for us internally. This initialization, this init constructor is gonna do that for us internally. in as much as we've declared the fields. So this data class is a decorator, right? And it also takes in some arguments, which I'll show you in a minute. But with this alone, right, we've declared the model, the data model, and we can see how that works. In fact, I'm just going to copy what we did here, right? And you'll see what we get. If I can type correctly, excuse me. So if we run our code again, oh, we need to print this out. So print Davis. And if you can see, voila, we did not do anything. We just, declare this data model like this, and then we passed in the variable, the field names. All right. And you can see when we print this out, it's showing us readable formats. We did not have to implement this representation method, right? All of this is done for us by default. However, despite the fact that it's done for us by default, we can always override it if we chose to. Okay, we can always override it if we chose to, and I can show you that. In fact, we'll copy. I'm going to do the same thing we did earlier again. So we can just want to override the representation to give us the same representation we were having earlier. So we have self. Let's just copy what we did earlier. I'm just going to copy that. Okay, and let's say return, and just like that. If we do this now, we get exactly what we had before, because now before, when we were using just the class and that we're implementing all the methods by ourselves, we had to tell it how to do this. There was really no default. The default he had was not exactly very human friendly, right? But we saw earlier that we have a very human friendly one by default. But let's say for whatever reason, let's say because of the format that we want to see, we had to overwrite it. This is how we'll do it, by implementing our own representation method. Okay, and that's how we would overwrite it. Another thing I would like to show you, I think I would like to show you here. Let's say we want to know, okay, if Raven, who has the best grade in physics, right, between Raven and Davis. So I'm just going to copy our representation of Raven. Our instantiation of Raven. So we'll give it Raven at 60 again. So what if we did something like this? What do you think happens? Now you see this says type error. This is greater than is not supported between instance of student and student, which is quite interesting. Okay, and I wish I showed us this earlier. We would also have had to overwrite some of Python. Each classes have like this magic methods, the special methods, right, where they are called special methods because they are actually special. We've seen two of them already. We've seen the init and we've seen repo. These are special methods. Another one that there is in Python, if you're not aware, is something called EQ. There are a lot of them, right? There are a lot of them that you can implement on your class. So we are going to return boolean, okay, and this will take order, which is actually saying that the other instance that you're trying to compare. And the thing about this is that we are getting this error because the student's object cannot be compared to student objects, right? I don't know if you understand what I mean by that. The object in itself, you don't know. I mean, it's just going to try to do the default comparison, which an object to an object is not exactly clear what you're trying to compare. All right. So we will do, we want to know if it's, excuse me, so we want to do if it's greater than, actually that's the implementation we want to do. But let's do the EQ one. Actually, I think we've seen the default implementation of that earlier, here. If we did this, so it says false because 80 obviously is greater than 60, and every other thing here. Raven is not the same thing as Davies. Age is not the same thing as 20 is not the same thing as 22, even though physics and physics are the same thing. Well, in this case now we are going to override it, because what we want to compare is, let's say, okay, the cost. If the costs that they are taking is the same, right, then we can say, okay, these students are of the same, say of the same class, or let's say they are classmates. So let's implement something like that. We say something like self dot course equals other dot course. All right, so if we do this now, earlier, if you notice, it said it was false. Now it says it's true. And in fact, let me show you that again. It said it was false, but now we've specified by ourselves, saying that what we want to compare when we are saying are they equal is actually the course title. Are the courses, are they students of the same class? Are they offering the same courses? So in this case, so that's what we've done. Back to what we were trying to achieve earlier, to see if Davies' grade was greater than, or is greater than Raven's grade. All right. If we run this now, we've seen this error before, right? So I want to show you another magic method that you can use to actually override this. So it's called GT. All right. And you can do the same, self and order, and then we return, boolean, true or false, is it greater or not. So what are we comparing now? As you can imagine, in this case we want to compare the grade. All right, is it greater than other dot grade? All right, and if we run our code again now, just a second ago it wasn't working, and this is how you would overwrite it, even in the same without the data class, right? Well, the beauty of data class here is that these features that we are adding here, we didn't have to do too many. We are just putting the custom things that we want to add, and not, we've removed those, the constructor and declaring the fields, all of those. You can see how many line of code compared to this one, we've done pretty much what we did earlier, right? So another thing I would like to show you is, take for instance now, let's say, okay, oh, there was a mistake in Davis' grade, okay, and the lecturer has realized that, and now they want to update Raven's grade. So we can say Davis' grade is equals to 75. All right, if we print Davis again here now, okay, what do we get? We see Davis' grade is now 75, not the initial 60, right? So which means we can mutate this date, right? We can update the value, okay. However, what if, let's say in this particular case, once your grade has been declared, no Jupyter can make that grade change. It's your grade for life, right? how would we achieve that in this? It could be value that you don't want it to be able to be changed. You don't want anyone to mutate it or anything to mutate this value in your project. How would you achieve that in with using data classes? You can achieve this by using, remember earlier I said we can pass a lot of couple of arguments as we see fit in this data class. You can look at them here, from the my text editor is giving advices here. As you can see, the default in it is true. Representation is true by default. EQ equal to is true by default, which if you remember earlier, all of those by default we didn't necessarily have to do anything. They just work, right? Except when we had to do our own customization of it, which is why we had to overwrite it. All right, so back to the matter at hand. We want to ensure that we cannot mutate the grade, we cannot mutate the let's say you cannot change the name, you cannot change the age, you cannot change the course, you cannot change the grade. Once you instantiate this class, that is final. So let's take, for instance, David's dot grade. We set it to 70 earlier. We don't want this to be possible, so there is this argument you can pass here called frozen. We say frozen to true, right? Remember before we did frozen to true was when we were able to update from 60 to 75. Let's say 75. Okay. We are going to make sure that is not possible now. How we do that? To achieve that, we just have to set frozen to true in this data class decorator, and let's see what that gives us. If all works, you can see we have an exception that says data classes frozen instance cannot assign to field grade. This is the exception, so you cannot assign anything to field grade, right? We cannot assign a value. Let's see if we can do for name. Let's say we want to change David's name to Raiding for whatever reason. We want to do that. We can do that as well. All right. That makes sense. You don't just change your name, right? So we can literally freeze the entire data. Like, okay, we don't want this to be able to be mutated whatsoever. Okay. Another thing we can do is set default values. Okay, we can set default value for our fields here. So let's add something else. Let's say we want to add something called bonus points. All right, let's say bonus points. Okay, bonus point is int. We want to set the default to 10. For whatever reason, this particular semester or there's a reason why the school had to say, okay, everybody gets a bonus of 10, or the lecturer said, okay, everyone gets a bonus of 10. Okay, and we want to put that in there by default. So that means if we do not even set it in our initialization, every initialized or instantiated value, when you instantiate the class, right, gets the default. So let me show you what I mean by that. You can see we only set name, age, course, and grade. If we print, we need to ensure that we are not overwriting it again here. We need to remove that. And if you see we've only done for these three, but these four values, but now we are saying bonus point as well again, which can come in really handy. Okay. Something else I also like to show you is, let's say you want to set this. Let me show you something. For instance, now if we remove name, or let's say we remove age, I think name is quite important. If we remove age from here and try to run this, it says students, this initializer on the constructor, missing one required argument, age. Okay, let's say we don't take that seriously. So if you don't have age, you don't have age. Maybe you don't know your age. We want you to be able to proceed, right, without causing an error. How would we achieve that with data class? So what we can do is use something called field. All right, each of them are field, but then there is a field method in the data classes, right, which you can use to customize each particular field. So we said age, right? So if you say field, right, we can say init. The initializer, we don't want it to be there. By default is true, so we want to set it to false, excuse me. So if we run our code again, student object has no attribute age here, because we can set a default, because we can actually set a default. All right, so since we don't want it to be initialized, let's say we are setting a default to 0. All right, so we know that if we don't have, if we see age that is 0, because no one is 0 years old, we can assume that age was never set, right? And you can say we are able to skip it in the initializer, and we're able to skip it in the initializer, and we don't get an error anymore, right? We are not set. We don't want it to be you don't want it to be a mandatory field to be initialized. Okay, so we've seen how to use the field. By the way, there are several other things you can set in here, right? You can look this up in the documentation. I'm going to put the link also below, in the description below. So what else can we do with data class? Another thing I'd like to show you is something called slot, right? And this is actually, if you had like hundreds of thousands of students, you don't want to you want this to be, slot is going to help. You might not really see the effect here, right? But you want to create slots for each of this instance that has been created are getting a slot, right? And when you have a lot of this record that have been created, this slot, is easy to do a lookup by, to do a quick lookup of the fields, right? By setting this to true, what essentially is happening in the older version of Python, and I am not entirely sure what version now, you would have something like, you would have had to do something like, say, underscore slot, right? And then you'd have to declare all the fields that you want in here, one by one, like this, right? Like so. All right, all the fields that you want to, more like, it's kind of a quote unquote like a cache of some sort, right, that you want, you would have to declare them like this. But now you don't have to do this. Just by setting slot to true, it's smart enough, data class is smart enough to know that, okay, you should set all of them in a slot. Okay, so and that is that. Something else, what else I would like to show you is that you can also override, like, even the initializer you can also override, right, if you choose to. Okay, you can also override. I'm not sure why you would want to do this, but for whatever reason, if you wanted to override it, it's also available for you to do so. So yeah, this is how you can use data class. There is a whole lot that you can do with it. As you can imagine, if you had like a model that is a lot much more longer than this, right? This which is why you probably even wanted to use a class for it in the first place. But if it's just for modeling data, it kind of makes sense for you to just put it use data class, right? Which is quite really helpful. You can see how much of the lines of code this has saved us. We just have to declare our fields, and that's about it, right? Which is really helpful. You'll find this really helpful. With this, we've come to the end of this tutorial. I hope this has been very helpful for you. Do if you find this really helpful, please consider subscribing to this channel. Remember to give us a thumbs up. It helps the algorithm to show our content as well to other people that will find this useful. Also, remember to turn on your notification bell so you'll be the first to know when new video drops on this channel. Until the next time, thank you. Cheers.